Our next speaker is Mr. Gautam Dutta, Senior Director Marketing, Siemens Industry Software. After starting his career as a CNC engineer at HAL, he worked in various capacities with ANSYS, Rolta, PTC, IBM, Silicon Graphics, and TCS. Out of 29 years of work experience, Gautam spent 24 years in the field of CAD/CAM, CAE, PLM as business consultant and sales professional. Gautam holds a BTech Mechanical Engineering from Delhi College of Engineering and an MTech in Aircraft Production Engineering from IIT Madras. Gautam, please welcome Gautam on stage.
Still good morning. Good morning, gentlemen and ladies. I have 20 minutes, so I will start without further ado. But before I kind of start with the core presentation, just wanted to set the context. Last year, we spoke about Siemens represented the same platform of Industry 4.0. My senior colleague, Mr. Samir Prakash, spoke about Industry 4.0. I spoke about digital manufacturing, if you remember. So what we decided this time is to go to the core of the issue and talk about the execution side. I draw attention to what Valentine mentioned, that we have to do small things and build those small things and then build upon the bigger dream of IoT of things and integrated smart manufacturing. There are many baby steps to be taken before we can call something that we have implemented called smart manufacturing done smartly, if I may call it. So many things have happened over last year since we met. Make in India. We all sat through and had a very heady launch of this very important initiative for manufacturing in India, followed by Digital India, and in couple of weeks or 1 week's time, on 15th of July, there will be Skill India launched. So both the platforms on which Make in India stands would have been with us in next 10 days time, and that gives a tremendous amount of responsibility and empowerment to the people sitting here to make things happen both in the skilling side and digital side. And today's presentation of mine is the digitalization. So I will move forward. Just before I start, this is following the Make in India. India was the partner at Hannover Messe in Germany, and this is our esteemed Prime Minister at Siemens Pavilion in Hannover Messe. And if you can read, the topic of the pavilion was digitalization in machine building. So we are on track as far as our subject matter is concerned with the world leader. And they are talking about Industry 4.0. We are talking about some of those aspects of Industry 4.0 within our initiatives of Make in India, Digital India, and therefore the Skilling India. So before, again, as I said, let's set the context right. What do we mean by digitalize? Digitalization. Make the digital thread a proactive agent in driving our business with fully optimized digital enterprise. At this moment, I would like to draw attention to what, and I would quote again the first speaker, and he mentioned that some economies are factor-driven, some economies are efficiency-driven, some are innovation-driven. It's a digital thread, the digitalization, that would make it possible probably at an economy to shift between an efficiency-driven and an innovation-driven. Think about it. If this economy is difficult, you can switch from innovation-driven and investment-driven economy to efficiency-driven, where you can save money. And that is possible only when you have a digital thread. And today I'm going to concentrate on manufacturing. This we have seen in the past. I'm not going to take you through every aspect of it. I think we have been talking about these dependence factors for many years now. There are two definitive areas that Siemens would be interested in sharing with the attendees here. One is discrete, one is process. I will leave process for my fellow speaker post lunch. I would concentrate on discrete industry in this session. This was the key slide last year when we presented Industry 4.0 of mapping the digital world and real world and bringing it together, and how simulation, PLM, application lifecycle management, EDA, TIA, total integrated automation brings these handshake between the real world and the virtual world. As I said, this year, I am going to talk more about the execution, and I have taken an example of an industry which is automotive. That's because automotive is the most progressive vertical in India, and it sets down a lot of learnings and baseline references for the rest to follow. Whatever is true for automotive is probably true for others as well, in its variations between industrial machinery, aerospace, defense, and many of these things are pretty common, so we can drive the learning from one to the other. The core of a digital enterprise, as we have defined many times, and I will repeat it, is lying between product lifecycle management, manufacturing executing system, and totally integrated automation. But as I said, I will leave these factors, these big words behind, and we will go to some of the execution issues, some of the issues that I think we should be able to take as a mandate within ourselves to be championing when we go back to our respective organizations. So there are 4 steps a digital enterprise in a small to medium business size enterprise can adopt. 1, digital enterprise software suite, industrial communication network, security and automation, and business specific industrial services. Now, before we get into these steps, what is important is to understand the product or services that we offer to the market and the processes that go about making that possible. So, if you look at the entire digital enterprise, from design to virtual production to real production, we are talking about computer-aided design, collaborative product data management, digital manufacturing, MES, and control and command. And this entire suite needs to fulfill the digital thread for controlling your entire design to manufacturing aspect, so that we are in control of business, not just making it more efficient and profitable, but making it more agile when the time comes to change the product, when the time comes to launch a new product, when the time comes to collaborate with new partners, maybe it's services, suppliers or new IP owners, probably we would be able to do it better. And as I just come from yesterday, attended the Automotive Engineering Show in Chennai, and there was a question from a youngster that how do you see automotive and manufacturing industry changing? And I could not but make an observation and learn from the electronics and computer goods as that market has evolved. The standards have evolved that, and today we can put together a computer at home, let's say within a day. You can buy the equipment, you can buy the best in class from the market and put it together. But probably we can't do it for an automobile today. And the reason is standards. But those standards are emerging. And there would be a time with the advent of higher levels of electronics in a vehicle, higher levels of standard equipment in a product called automobile, with the changed definition, that we can put together an automobile at home, buying the best in class. And there would be another set of economy where automobiles like computers are produced by mass producers and mass developers, and they would drive probably through IP owners at the first layer, and then the subsystem suppliers, and then contract manufacturers. And the business would be done on the edge of IP and process, if you understand what I'm talking about. Somebody mentioned, I think it was the first speaker mentioned Apple as an innovative product. Apple is manufactured by a contract manufacturer today, while the process and the IP is owned by somebody else, correct? So if we can be in control of our process, if we can be in control of our IP, that is where another question that we faced yesterday was very interesting, was how to compete in the globe. We are of the opinion, and we have discussed this within Siemens quite often about India. I don't think there is another place for another economy for volume scale industrialization like China. There is not enough market to have another volume country emerging for volume manufacturing. That means we have to do something different. We are smarter people, we have good engineers, we have fantastic software workforce with us. We can make the smarter products, which is what is manufactured and needed in this world. That would means integration of different verticals of electronics, mechanical, electrical, hydraulics, all put together, developing this digital thread of product development up to manufacturing, making it extremely agile, and supplying to the world the smarter products that we need, whether be it power, whether be it transportation, mobility, aerospace, or wherever it may be required. So with that background, I have taken one example and just trying to define how we can make our processes understood to ourselves so that we can create that digital thread. And once I start that example, you would realize the pattern in which I am doing it, and whatever may be your business, you can go back and practice that and ask yourself, where do you stand? Before I start that, a couple of examples. Some of them are interesting. Red Bull, winner of 4 Formula 1s in continuation. Of course, fantastic drivers, fantastic product, but at the core of it, developed with Siemens solutions of the digital thread, by the way. Another company, Roventa, makes consumer goods, again with the Siemens solutions and the digital thread. Daimler, including the R&D that exists, that works out of India, design anywhere, requirements defined anywhere, manufactured anywhere, using PLM software and MES solutions from Siemens in making this world-class product, which defines every year, every time it launches, it defines a new baseline of standard product. So, taking that, let's look at an example of an automobile. As I said, it can be, time is not sufficient here to take all the products and all the verticals, so I have taken automobile. And let's look at what are the critical success factors for an automotive launch. Do we believe that an automotive launch is a very important event? And it depends on multiple factors, but most important 3 that the manufacturers and product developers have identified. It's the first time quality, ramp up to volume, and reducing the cost overruns. To be able to control these 3, they are able to control the launch. There are many factors that are part of an automobile, and I will not be able to take all of them. I'm taking a few of them to show you how a digital thread can be drawn. To begin with, let's look at powertrain. Now, powertrain of an automobile is no different from a gearbox of a machine tool. It's no different from a mechanized back end of a food processing machine or a textile machine. So, draw your own parallels. What is the most important thing that today? These are the many factors. So, I cannot, again, paucity of time, cannot take all the factors. I've taken one. One of the most important, lightweighting a vehicle. This is probably one of the most important driving force today in the automotive final product. Lightweighting means reducing the weight of the body, reducing the weight of the powertrain, the gearbox, the entire vehicle, improving the fuel efficiency, therefore making it more comfortable, drivable, safe, everything that goes with it. What are the business processes? So step 1, after we have arrived at what are the trends, that what are the challenges that we have to face, what are the business processes that get impacted? manufacturability analysis. I think there were a couple of mentioned on design for manufacturing analysis, design for servicing analysis, design for maintenance analysis, design for quality analysis. So all that manufacturability factors are to be analyzed. So that's the business process. These are the baby steps that we were talking about before we talk about Internet of Things and integrated manufacturing and smart manufacturing. Tool and fixture selection, NC programming, CMM programming if you are getting into coordinate measuring machine because it's powertrain and very highly accurate components, tool management and shop floor connect. So these are the baby steps. If you really see the thread here, unless we have defined our bill of process and bill of material, it will be very difficult to start creating a digital thread for a powertrain. Correct? I'm not getting into the details of it, but there is a one layer deeper explanation of the business process. Let's say manufacturing. So what kind of manufacturing, part manufacturing measures that you have taken and defined while you are modeling will define the automated process output of those. So these are the factors which today we are doing entirely manually, except for very, very few high-end companies in automotive and probably a bit in aerospace. Most of this work is being done in India manually. Manually people are defining what manufacturing should I do, what process should I adopt to be able to arrive at this accuracy. Whereas these are things that can be defined and need to be defined if we have to create a digital thread. Because again, as I said, digital thread means people who do this repetitive work, do it and control the IP of the process, which drives the product development and product manufacturing, rather than concentrating on a product process. Authoring a product process, manufacturing process. They are creating the knowledge for the company, and that knowledge stays because those are referable and that can be used for next version. Let's look at final assembly. Final assembly is where all these components and subsystems come together in an assembly line in an automotive. What is probably the most important factor in a final assembly? That these are many, and I have picked up new plants. What does new plants mean? One of the things that you must have noticed in recent 15 years that lots of automotive manufacturers in India are doing are going very near to the customer manufacturing. So Hero Motors had a 25-year-old plant in Daruhera and in Gurgaon. They replicated in Rudrapur. Now they are talking about doing it in Gujarat. They will be talking about doing it in South. They have created very efficient manufacturing processes over the last 20 years. Now is the time for replicating it in the new plants. They can't recreate those process improvements. So the replication is the challenge for them. That's what new plants is all about, is to bring about implementation of those processes that you have already gone through. So what are the business processes that a final assembly operation depends upon? Bill of material management. When I say bill of material, I mean engineering bill of material. Bill of process management, which is the derivative manufacture. Those who are part of automotive, can anyone guess how many manufacturing bill of material at an average exists with respect to a single engineering bill of material? Let's say an engineering bill of material for this would be this body, some 20 odd parts, correct? That's the engineering bill of material. That's what the designer makes. Guess how many manufacturing bill of material exists for an average vehicle? About 60 to 70. So that means if there is one design change, 60 to 70 bill of processes, manufacturing bill of material needs to be changed parallelly. And the reason is simple. Some plant, this part comes as an assembly. In some plant, this part comes separate. So you have separate manufacturing bill of material. Just to give a thumb rule to it. Correct? So that's the complexity of this. So unless we define our manufacturing bill of material, it's very, very difficult to create a digital thread. the tools and equipment that go with it, layout planning and costing, process validation. If you don't have a process, there is no process validation. If you have a process, then you have a digital validation. Then you can create the digital thread of the final assembly operations. And then, of course, the production support through MES and TIA, as I just explained. So again, I'm not going to go through it, but with every new product, a shop floor manager has to do line balancing. I wish everything in this world took equal amount of time. Then there was no problem, but it does not. A process A, operation A takes longer, operation B takes lesser time, so you need to have buffer if you have to maintain a flow of manufacturing. So line balancing is important. Last example I'll take is body in white. This is probably the most expensive part of a vehicle, where a vehicle is assembled, welded by robots in an assembly line. One of the things that holy grail of vehicle manufacturing body in white is to make multiple models on the same line. That way you save a lot of money, okay, because every line costs millions of dollars. That is possible only when we have business processes of process planning. Equipment selection means robo selection, gun selection, the tools, fixtures selection, PLCs integrated, process optimization defined, and virtual commissioning of those machines offline on a computer defined. And then we start making the digital thread of from the process to the assembly and to the infrastructure that we would require. So as I said, coming to the end of it, that's I just finished my 20 minutes. So I had to rush through. These three are only examples. Within your respective organizations, there would be at least at an average of 15 to 20 digital threads that you need to optimize. Maybe you start with 1 or 2, quarter after quarter, you have to make a plan that this is a digital thread that I would define slowly, so that we can get into the smart manufacturing mode, and Industry 4.0 or whatever we adopt in Make in India and Digital India is made successful with time and effort. Thank you.